This attempts to survey every person in a population. We have a country. I think probably most countries attempt to do this. We have a U.S. Census survey. And it's every 10 years. I think we're coming up on it in 2020. I think it's the end of each decade or the beginning of each new decade. Every 10 years, it attempts to contact every head of household. And I probably should know. I think if I remember right, they send out a big mailer to every home that they have an address on, which is pretty much every home. But can you see a potential problem with that? People don't do it. There's non-response for sure. And homeless, absolutely. If you're homeless, how do they contact you? So they actually send people out. They hire people temporarily for a few months to literally go knock on your door and say, hey, we didn't get your census back. You got to do that. And they send people out in an attempt to contact folks. You know, you got your hermit who lives way up in the mountains somewhere that gets mail like once a year perhaps or something. You know, I don't know. Okay, that kind of finishes up day one. Let's look at studies. We have an observational study. An observational study is where a researcher observes subjects without attempting to influence a response. That's how I felt this morning when my alarm got me up at way too early on Monday. So the other day we talked about a problem where people were asked directly, face to face, do you wash your hands after you use the bathroom? And I think if I remember the book right, it said something like 95% of the people said, oh yeah, I wash my hands every time. And then a researcher went into the bathroom and just kind of hung out and observed how many people washed their hands. And it was about 10% less. But do you think that number would actually be less than that even if the researcher wasn't in there? I think so. I think the fact that the researcher is actually there observing would encourage people to wash their hands. So I think the real number would be less.
Yeah, some guy with a clipboard in the bathroom checking you off.
Exactly. That would be a little unnerving, wouldn't it? A guy in the clipboard. Hey. Hey, what are you doing in here? Oh, I'm just seeing if you wash your hands. Okay, I'm going to wash my hands. Okay. All right. So even though they attempt not to influence a response, I think that there is argument that there are probably situations where they do. An example that I was thinking of is when I taught driver's ed, I gave an assignment for kids to go out and just observe an intersection. And in that case, I don't think somebody sitting back and just watching people run red lights is going to influence their decision to run the red light or not, unless you're sitting in a black and white with the bubble lights on top. That might influence their decision to run the red light, right? Depending on what you're sitting in. Okay, the next one is an experiment. In an experiment, the researcher deliberately imposes treatment on individuals to measure a response. The researcher deliberately imposes treatment. Sorry, put that up a little bit higher there. The researcher deliberately imposes treatment on individuals to measure a response. Now, when I say individuals, when I say subjects, they're not really interchangeable, but they are in the case where it could be subjects or individuals. And what's the difference? Individuals are just experimental units. You can use either term. They're non-human. So mice, maybe mice, or you might be looking at miles per gallon in different cars or something like that. Mice, miles per gallon. Could be all sorts of things. Anything that's non-human is either an individual or an experimental unit. When we talk about subjects, though, now we're talking human. Or you could say they're human experimental units. So an experiment can also be on subjects, and an observational study could be on individuals. So it depends on what you're studying. So subject is human. So what if I design an experiment to test the effects of smoking on humans? And I'm going to assume in here that all of you have made the correct decision to not be smokers. Okay, that's my assumption. I hope it's right. And I come in and I say, I'm going to have an experiment here, and I'm going to see what smoking does to the human body. So here's my experiment. You guys are all going to be smokers. Okay? Nice. Yes. I'm even going to buy the cigarettes for you, okay? You guys smoke, right? And you guys can't have any fun. You can't smoke at all. Okay? Right? No. Nothing legal or illegal. Okay. You smoke those cans of cigarettes in the old days? Okay.
No. When you do the Smarties,
Right. Exactly. Okay. So there are times where I can't do an experiment because because it would be unethical, right? It would be unethical for me to get a sample of people and say, okay, you guys, you're going to smoke, right? Because yeah, that's why you let the mice smoke, exactly. So, but we can do an observational study on smoking. That would be just fine. In fact, by using observational study, we've decided, or we've found out that, in fact, smoking does have a higher incidence of lung cancer, right? So if you smoke, you're a lot more likely of dying of lung cancer than if you don't. There are other problems too. All right, everybody with me so far? Okay, we want to talk next about association and causation. Part of this piece of my notes, I actually couldn't find referenced in the new book. I really like the new book, but I think there's a piece missing here. Now, we've learned that correlation does not necessarily suggest causation, right? But it can. So causation occurs when some variable x, some explanatory variable, has a direct effect on the response variable y. So changes in x affect changes in y. You can think of it as a function. It works out to sort of be a function. Although x is not going to change every y in exactly the same way as all others, it's just there's a causation. One causes the other. If you smoke, you're more likely to get lung cancer. Okay. The next one is common response. And if I were to draw a common response out, it would look like this. Here's an x, over here is a y, and I've got a z. And z affects x, but it also affects y. So changes in both x and y are caused by an extraneous variable. A term that I really like, especially for Halloween, but is really no longer used in stats anymore. But you can still use it and they'll know what you're talking about. Lurking. A lurking variable. So we've got causation, common response, lurking. So a great example of this is an example that I gave you earlier in the year. If you eat hot dogs, then you're likely to get lung cancer, more likely to get lung cancer. What? Well, that's a common response to smoking. Smoking would be your Z factor, if you will, your extraneous, where Z causes, Z as in smoking causes the lung cancer, but because of the expense of buying cigarettes, it also causes you to buy cheaper protein, right? So you buy more hot dogs because you're spending your money on cigarettes instead of tri-tip or, I don't know, whatever. whatever the expensive stuff is that you eat. So this one I didn't see in the notes, or I didn't see in the book anywhere as I was looking through it. I was kind of surprised. Common response I think is worth knowing a little bit about. The next one is confounding. So we've got causation, common response, and confounding. Confounding works like this. There's an x and a y, and x maybe affects y, but a confounding variable also is affecting y. So the effect of x, if any, is confounded by the effect of an extraneous variable. Trying to remember the example I gave last class. I got an idea. How about x is a boy and y is a girl, and z is the girl's ex-boyfriend. So the relationship between the boy and the girl is confounded by the fact that the ex-boyfriend continues to send texts to the girl. How's that for confounding? Does that work for us? Okay. All right. So that's it for notes today. Shall we look at a couple problems? Oh, there goes Emmett. He's going to go with the what ifs.